Hello everyone, and welcome to our presentation on EyeQ. Our project is proudly sponsored by Professor Ruchin and Professor Jinli from the UCI School of Medicine. Now meet the team. I'm Tej, who is focused on backend engineering, and we have Swaroop, focused on AI and machine learning, and Bala Aparna handling the infrastructure of this project, and Aman Singh on the front end. So the core problem we are addressing is basically in the vision science, the vision researchers struggle to navigate the massive PubMed literature. They are spending countless hours on slow manual analysis, trying to connect gene lists to the biological pathways, and often this leads to a missed scientific insights. So this inefficiency is a major roadblock to discovery. For this, our solution is IQ. It is an advanced AI-powered RAG assistant. Basically, IQ transforms this process by performing semantic search, deep pathway analysis, and evidence-based summarization. This allows researchers to instantly find the most relevant papers and uncover the critical biological insights specifically within the vision domain. Now let's move into a live demo of IQ in action. So this is our chat interface. Let's start with a basic question about a common eye condition. I will ask, what is age-related macular degeneration? So it has generated the response. Now let's go deeper in searching more about genetic factors associated with AMD. Now we are searching the PubMed papers. Notice the system is searching over the indexed PubMed database, which is more than 200K articles, and retrieving the relevant information. Yeah, here's the answer with the scientific context. Notice the citations at the bottom, and each answer is backed by the peer-reviewed research. So this system uses RAG to find the relevant papers and generate evidence-based responses. Now watch this. I will ask a follow-up. What are the treatment options for it? Notice I didn't repeat the AMD. The system remembers our conversation context and it understands it and provides the treatment options. Yeah. So this shows the conversational memory capability, which is essential for the research discussion. So beyond answering these questions, the system can also analyze the gene sets. Let me input some related genes. As you can see here, it identified 2000 gene sets and it queried to the MSecDB and provided the analysis report in a simple plain language, which you can either export as a CSV or export as a JSON. Yeah, this is a brief about the project, and we also have the chat saving feature where you can create a new chat. You can also continue your previous chat discussions from here. You can also save your chats. Supports more than 100 concurrent users currently. Yeah, this is it. We can also show the autoscope detection, but due to the time limit, I will move on to the other parts of the presentation. Moving on to the core system components that power the IQ. So our process begins with document parsing. This involves PDF parsing with OCR, text chunking into manageable pieces, and a robust cleaning pipeline. Next is search and storage. So we basically utilize a RAG pipeline built with the LangChain. Our vector search is handled by ChromaDB for both similarity and hybrid retrieval, and with PostgreSQL managing the metadata and Redis for the caching. And we use sentence transformers for our embeddings. And coming to the retrieval and reasoning, we leverage a mix of large language models, including GPT-4 Turbo and local models like Phi2, for the precise information extraction and reasoning. And finally, the pathway analysis. For this, we use the components like GSEA Pi, Fisher's test, and FDR correction, and MSecDB to perform the pathway enrichment and to perform the summarization and provide the deep biological insights. Let's review the final system performance. We basically focused on four critical metrics. First, the speed. We achieved a sub 2-second response time on GPU and an optimized 5 to 10-second time response on the CPU. Second, the scale. IQ has indexed over 200K PubMed articles, and supports more than 100 concurrent users. Third is the reliability. We have maintained a 99.5% uptime through a stable microservice deployment using the Docker. And accuracy, our vector retrieval accuracy is over 85%, and the pathway enrichment process consistently completes in less than 1 minute. Regarding the system integration, EyeQ is built on a modern, robust stack. So our backend uses a fast API and the LangChain with databases including PostgreSQL and ChromaDB. And for the front end is powered by the Next.js and React. So we integrate with critical external APIs like PubMed for our data, and we mostly rely on Docker and Nginx for our infrastructure. In summary, here is the value EyeQ has delivered to our researchers. So we have achieved significant efficiency gains by dramatically reducing the manual literature review time and creating a unified workflow for search and pathway insights, leading to a faster decision making. And coming to in terms of automation achieved, IQ provides automatic evidence extraction, and also it automates the pathway interpretation from complex gene lists, all within consistent and citation-backed responses. Finally, we have the validated research value, which has to be proven the feasibility of a reliable domain-specific AI assistant with high accuracy for vision science use cases, laying a strong foundation for the future clinical or lab integration. Finally, let's look at the next steps. For the IQ project, we have three key priorities. First, we'll ensure a smooth handoff. This includes providing Dockerized services, all necessary deployment scripts, and a clear roadmap for the future expansion. Mostly 70% of this is already done. Second, we must address the current limitations. Specifically, this means tackling the CPU-only performance bottleneck and automating the dataset refresh process, and also developing a comprehensive pathway visualizations. And the third, we plan to enhance the system further by implementing automated PubMed updates and fine-tuning a domain-specific large language model and exploring future multimodal capabilities. That brings us to the end of our presentation. Thank you all for your time and attention. We would especially like to thank our project sponsors again, Professor Ruchin and Professor Chinli, and offer a special thank you to our Professor Moshipur and Professor Emily for their guidance and support throughout the capstone process. Thank you.